Welcome back to Trick Equals Treat. Meet today's suspect. It's a classic oddball. Literally, a triangle with consecutive odd integer sides 3, 5, and 7. Our mission, should we choose to accept it, is to find the exact measure of angle C. That's the angle between the sides 3 and 5. Now, most textbooks would scream, "Use the law of cosines!" But let's be honest, that formula is a mouthful to memorize. We're going to solve this using nothing but our old friend, the Pythagorean Theorem. First, a quick vibe check. Is this a right triangle? Let's test the legs. 3 squared plus 5 squared is 9 plus 25, which equals 34. But the hypotenuse squared? 7 squared is 49. 34 is definitely not 49. Because the long side is too long for the theorem, this angle has burst open. It's an obtuse triangle. It's wider than 90 degrees. So, no right angle? No problem. Here's the trick. If the problem doesn't give you a right angle, build one yourself. We're going to extend the base and drop a perpendicular line from the top. Let's call this intersection point D. At once, we have a right angle, angle D. It is exactly 90 degrees. Look what we just did. We turned one awkward, obtuse triangle into two beautiful right-angled triangles. The small red triangle on the left, triangle ADC. The giant blue triangle spanning the whole figure, triangle ADB. Now, we have a ghost leg, this little extension segment CD. Let's call its length x, and they share a common wall, the height h. We can write two Pythagorean equations. For the small red triangle, triangle ADC, h squared plus x squared equals 3 squared. So, h squared equals 9 minus x squared. For the big blue triangle, triangle ABD, the base is massive now. It's the original 5 plus our ghost leg x. 5 plus x squared plus h squared equals 7 squared. H squared equals 49 minus 5 plus x squared. Here is the beauty of this method. We don't actually care about the height. It was just a bridge to get us here. Since both equations equal h squared, we can set them equal to each other. 9 minus x squared equals 49 minus 5 plus x squared. Watch the magic happen. When we expand the right side, the x squared terms appear on both sides and poof, they cancel out. We are left with simple elementary school arithmetic. 10x equals 15. So, x equals 1.5. We found x is 1.5. Why is this number a treat? Look at that small red triangle again. The adjacent leg is 1.5. The hypotenuse is 3. Do you see it? The leg is exactly half the hypotenuse. In the world of trigonometry, if the cosine of an angle is 1.5 over 3, which is 1/2, that angle is math royalty. It's exactly 60 degrees. So, the exterior angle is 60 degrees. Since angles on a straight line add up to 180 degrees, our mystery angle C is simply 180 minus 60. 120 degrees. By building a little construction on the outside, we solved what was hidden on the inside. That's the trick. But wait, I can hear you asking, what if I wanted angle A, the top one? Same trick, different direction. This time, we drop the ladder, the perpendicular line, inside the triangle onto side AB. We split the triangle into two. We set up the Pythagorean Theorem twice, subtract one equation from the other, and boom! The squares cancel out again. It works for any triangle. You essentially just derived the law of cosines without the headache. Whether you're prepping for the SAT, a math Olympiad, or just love a good puzzle, remember, sometimes you have to think outside the triangle to find the answer inside. See you next time for more math treats. Trick equals treat.